Hello Professor, in this video I'm going to be talking about Lab 8 with the servo motor. So one of the challenges for this lab was doing some of the math and calculating our CMP and low values for different angles, and it was the math behind it. In lecture we talked about, as an example, the high-tech servo motor, but in this case we're using the SG90. So instead of going from, I don't remember the high-tech motor, maybe it went from 0.9 to 2 milliseconds. This one goes from 0.5 milliseconds to 2.4, and that changes up our math. So I'm going to be balancing between monitors, but for our SG90, our pulse width signal is from 0.5 milliseconds to 2.4. We're going at 50 hertz. If we divide 1 over 50 because it's frequency, our time is going to be 20 milliseconds. Our resolution is 0.001. So we want our load value to be strictly less than 65,000. So if we take the 20,000 divided by a resolution, we get 20,000, so we're good there. Now, our clock is 1 divided by our resolution. And once we do that, we get 1 megahertz. Now, this is the part that I want to talk about that would be significantly different than the example in class. And before I explain this, I want to see where we get this formula from. So, this is for right-aligned PWM. But since it's doing strictly left-aligned, I will only be using this side. So once we have our load value, we're going to multiply that times 1 minus the duty of the angle. So 0% for duty is going to be 0% for CMP. Now to find the load, we're going to take the PWM timer and divide it by 50 megahertz, and it has to be strictly, or rather less than or equal to 65,000. We already found our load value to be 20,000. So going back to our math, now what we have to do is take our 0.5 milliseconds, which remember we get from here because that's our range, so that's in different notation, but it's still 0.5 milliseconds to 0.4, and we divide it by that and we get 0.25. So our duty for 0.5 or for 0 degrees is 0.025. Now we do 1 minus 0.025 times 20k, and we get 19,500. And we do something similar here. We get 2.4 milliseconds divided by 20 milliseconds. Milliseconds cancel, we get 0.12. Go over here, and now we get that our CMP for 180 degrees is 17,600. And as you note, that is the same values we have here. And also our CMP0 is greater than or equal to our CMP, which is greater than or equal to our CMP 180. Okay, so going back to the code, from here we have our, kind of speaking through it, I know I wrote comments on this in the lab report, but first we're going to initialize our CMP value and start off as CMP0, and you'll see shortly why. So during our infinity loop, we are going to output our current CMP value, and the first go around is going to be at 0 degrees. Then if our CMP value is equal to CMP0, we're going to wait 1 second. Otherwise, we're going to wait 50 milliseconds, and we're going to decrement by 20 our current CMP value. Now, if our CMP value is strictly less than 180, CMP 180, we're going to update our CMP value to be CMP 0, and that's our infinity loop. Talking about some of the GPIO configurations and our PWM setup. So these are some important things that we need that we get from the class website. So this is PB6, so it's module 0, generator 0, PWM 0. We're going at 16 megahertz. Our PWM divisor is 16, and our frequency for it is 1 megahertz. And our PWM frequency is 50 hertz. This is our load on our CMP. This here is our setup PWM, and we're using module 0. Module 0. We have to enable the clock. Here it's for the left, Right here is for the left of the line, PWM. Here is the GPIO setup. It's quite simple. We only have one pin, and it's PB6. So we're going to use port B, port B, port B. This is the pole control register for port B, pin 6. This is the one set that we have to do, and then this is the pin that we're using. Okay, now to run this, one thing about the circuit that we need to do is, because the microcontroller is not going to have enough voltage and current, we need to use our power supply. And one big thing that I feel like a lot of people might forget is to ground the board to your breadboard, which is connected to this, which is connected to power. Now the circuit for this is quite simple. You have your RC motor, your servo motor, sorry, and you only have 3 connectors to worry about. You have your ground, your power, and your PWM signal. So my power just went out, and I'll put it back in. Now, if you notice, it's all connected, but it's not working. What I need to do is connect this, and let's restart it. Oh, it's just working. There we go. I don't know why it wasn't working. There we go. Now it's working. So it's not going, it's going the 180 degrees. I'll spin it this way so you can see it go the 180 degrees. And that's really it. So I'm going to stop this power source. And that's this lab. Thank you so much, Professor, and have a good rest of your day.